An object is initially at a point with the position vector 3i minus 4j meters, moving with a velocity of 2i plus 3j meters per second. It's experiencing an acceleration of I minus 2j meters per second squared. In part A, we want the change in displacement in the first 5 seconds. So we're going to use s equals ut plus a half AT squared. But remember, these quantities are vectors. So the initial velocity is 2, 3. And we're using 5 seconds. Then we've got a half, and the acceleration is 1, negative 2, and then we've got 25. So that's going to be 10, 15 plus 12.5 negative 25. And so that is 22.5 and negative 10 meters. And we could, of course, write that back in IJ notation as 22.5 I minus 10j meters. So when we come to part B, which is its position after 5 seconds, remember it started at 3, negative 4. And then it's gone 22.5, negative 10. So that's going to put it at 25.5, negative 14. So we now want the distance travelled in the first 5 seconds. Well, we know that this was the displacement. Distance is the magnitude of displacement. So it's going to be the square root of 22.5 squared plus 10 squared. It's just Pythagoras' theorem. So we're going to calculate that. So we have the square root of 22.5 squared, add 10 squared, and that's 24.6 meters, correct to 1 decimal place. So now we're going to move on to velocity, and I'm going to use v equals u plus a t. So that's going to be equal to the initial velocity is 2, 3, and then the acceleration is 1, negative 2, and the time once again is 5. So that's going to be 2, 3 plus 5, negative 10, which is 7, negative 7 meters per second. Of course, you could put this back into an IJ type notation. So finally, we want the speed and direction after 5 seconds. So this tells us that we are going 7 across and 7 down. Clearly that's an isosceles triangle, so this is 45 degrees. And v there is just going to be the square root of 7 squared plus 7 squared. So that's the square root of 98, which is let's call that 9.90. So 9.90 meters per second, 2 decimal places, and 45 degrees below I, or negative 45 degrees, or whatever you wanted to call that. But 45 degrees below I, together with this diagram, really does describe the direction.